Hello, gentlemen. We are coming to the close of this event, and I am sure you're tired. You found the time to come, your company or you spend the money, and I will talk about continuous integration, and everyone knows what it is. Yeah, right? If I would like to ask you 5 years ago what's continuous integration, I expect that half of you will raise a hand. 5 years, everyone knows the continuous integration. I am again speaking about continuous integration delivery. What's wrong with it? It's simple. It's Jenkins, server, and that's all. Why it doesn't work? Let's assume that we would like to build with you some kind of assistant, robot, for home, for work, gentle, smart, low consumption, not eat a lot, not like I am. Nice view, yeah. We build it, and in the end of the day, when we build it, we found that it's Frankenstein. Screws there, through there, yeah. With new technology, with each new technology, it's happened again and again. The same was with Scrum and Agile. The same with continuous integration delivery. When we come with new technology to the market, we think, okay, it's a panacea, it will help us. There is no more pain for deploy. Mergings will be easy. Doesn't work. Why? Or even a more dramatic question. Do you think that continuous delivery it's a mandatory for any project? The answer is no. Because each solution requires something. It costs us. It costs additional effort, knowledge, additional power. Why and when we need a continuous delivery? Or other question, when we do not need continuous delivery? A few words about myself. I'm too old. I'm 30 plus years in technology. I have been a hardware engineer, software engineer, project manager, business developer. I have a second education like in psychology, Bible psychology. Yeah. I do counseling. Today I'm working in a Ring company. Ring is an American company with a branch in Kiev. 1 year ago, our branch had been 13 persons. Today, we 450. For 1 year, it's more than 10 times more. We are second customer in Amazon after Netflix. It's a huge amount of instances. If I will tell you that in our department continuous delivery work, I will lie. No. If I will say you we have no continuous integration delivery, I will lie. We have. But again, we found the same problems that I discovered during last 5 years, and I will try to accumulate these problems. Actually, only three problems that stop continuous delivery process and make it really hard. Okay, so what I will talk about? A little bit about mutable components in RD. Even tomorrow, you will find new technologies. These points we mentioned will exist. And we will talk what it is and why the technology will find new solutions, what they would like to solve. The second part is mostly my speech, what's the major fails in continuous delivery. And here we will also find an answer where we do not need to implement continuous delivery. And in the end, I will try to provide these solutions that I found useful. Okay? So, all of you know SDLC, yeah? Cycle. This will be continuously. Nobody, we will die, this will live. Okay? This cycle will live forever. And if we put it in a time, we will have a periodic sinus, like a cycle. And integral of this function is actually the power that we need to put to deliver something. To solve this problem, to make it minimal, continuous delivery come to the world. Where amplitude is a number of time or developers that we need to implement the feature. And the time is actually the size of this cycle. And if the size of this cycle, a period of this cycle, is few hours, the integral of the sinus will be less. This is very, very simple answer why we need continuous delivery. To work automatically. I expect that you know V-model, yeah, waterfall. I like V-model because in those times we think before implementing. Not like in Scrum when we need to provide immediate output. And from the testing point, we're coming back when we make a bug fixing to implementation, when we need to change something in design, in refactoring, and new features or new requirements. And of course, each time when this is bigger, the much energy should be put to solve market requirements. So all of we are talking about to minimize this cycle, because end of this cycle anyway here in a testing, in a production way. A little bit about continuous delivery itself, what it is. I found 12 points to describe continuous delivery. First of all, it should maintain a single source repository, because if we have no single source repository, it's terrible. A few different departments. We in our company, Ring, have 4 different departments in 4 different locations: Argentina, States, South Korea, Ukraine. Very, very difficult to manage them if it's not the same source repository, source code repository. Automated build, sure. Make you build self-testing. If you have no self-testing, no continuous delivery at all will be. Everyone commit to the mainline every day. Every day, even the task is big, he should commit it as quick as possible. Every commit should build a mainline on integration machine, something like Jenkins. Continuous integration is an attitude, it's not a tool. It's impossible to provide a set of tools and say, okay, we have it. It's point of culture of all the teams that work in a company. Without it, you have no choice to make a continuous delivery, like Agile Scrum or Kanban. All of the components should work synchronously and understand why it needed. Fix broken builds immediately, as quick as possible. Keep the build fast. We will talk about it later. Test in a clone of product environment as much the same as it possible. Green, blue, it's perfect. But unfortunately, in our case, again, in Ring, we can't do it because it's thousands of instances. We cannot duplicate this. It's too costly, too expensive. Make it easy for everyone to get latest executable, and everyone can execute it. Because truly, we have no automation deployment at all. Absolutely automated. it should be a person that press some knobs or fix something by hand, but it should be in Confluence, it should be written, it should be known that each one of developer can do deploy. This is actually what is continuous delivery and his parts. Now, the three primary problems that stop continuous delivery, and actually this is the answer why and where we do not need it. The first one is a monolithic code. And by the way, is it terrible to have monolithic code? The answer no, really no. Low coupling it should be, but monolithic code, it's a good solution for proof of concept MVP projects, for a project that you wouldn't change frequently. You deliver it to the customer, and that's all. It should be monolithic code, because when we will talk about different parts, it's required from us additional effort. It will cost more. And good solution for a project start from monolithic code, and after came to with refactoring to separate parts that I expect today we talked a lot. It's a first point, but with monolithic code, we will have no continuous delivery. I will explain after why. The second point is to design test suite, not a test design. Design a full test suite, full component, because testing has a different parts and different approach. All of them should be covered. If we will not have it, we will not have a continuous delivery too. And last one, we should have a pipeline that stay in backend, backbone of the project. If we have no continuous delivery pipeline, nothing will work. And generally, DevOps, sysadmins, infrastructure engineers, whatever, code whatever, they have secret keys how to deploy. This is terrible. It doesn't work. Continuous delivery in such case doesn't work. So let's start from the first point. Monolithic code base. Again, sometimes it's good, but if you decide to work with monolithic code, forget about continuous delivery. When I'm coming to the project, and generally each team tell me, oh, no, we have no monolithic code, we have different services, we work with microservices. Okay, very simple 3 points where we can decide, is it monolithic code? Slightliness. If your developer goes to make a coffee break during the build, it is a monolithic code. If someone will tell you, oh, please, hold a second, application is coming up, it's a monolithic code. If your automation tests take hours, you're coming in. You do not need even to look for a code. If one of them exists, believe me, it's a monolithic code. You will not have a continuous delivery, efficient continuous delivery, if one of these exists. And generally, all of them in the same time exist, if it's a monolithic code. Why? Again, because it takes time. Because in this process, you have much more energy. Integral of the function begins like this. More people should work, more time will take. Very simple. It's very simple rule of the humanity. Another story. When new developer, unfortunately, we have very quick changes of developers. Some people tell me, okay, so Dov, not 100 times, not 100 times, 100 times. Why? Because for a simple change, developers that know the code spend between 5 to 15 minutes for a few lines of codes. Very simple change. And someone that does not know code spend between 1 and 3 hours, 100 times more. It costs a lot of money to handle a monolithic code when you have a huge files, huge line of codes, and of course you have a correlations between them. You touch it in one place, and you get result in others. You know, we have a joke that one programmer worked from home, something going wrong, he changed it in one place and crashes. And his son comes to him and say, okay, father, why the sun is rising there and coming there? Son, you checked it? Yeah. It's work. Do not touch. This is a monolithic code. When you touch in one place, you get it immediately in another. It's not my fault. No. I changed only the color of the page. It's not my crash. All of us hear these words, yeah? All of us know this story. It's not mine. When it's monolithic code, you have no owner of the code. Agile again, that's Scrum. You need to fix, and we need it now, right now. And story begins. So, now I will talk what's an impact we have from monolithic code and why it doesn't work in continuous delivery at all. Slow build. What is slow build? Slow build, it means that nobody wishes to stay and sit and wait for a build. So what the program is doing, they don't build even locally before they making a pull request. The continuous integration server starts by night every day in a good condition, sometimes less, yeah, in few days. This point is important for me when I speak with managers, with product owners, my boss or someone that order actually a project. When I come to him and tell, okay, we have a monolithic code, we need refactoring. What he should tell me? I'm sorry, I paid the money. You made a project, it's your fuck up. You should find the time how to fix it, okay? Maybe someone doesn't hear such words. I'm regular. When I'm asking about refactoring, each time I get the same words. What's my solution? Because businessmen understand only the business, only the money. How I do it? I talk, okay, look, 1 or 2 years ago, we start the project. We work like Agile with Scrum to come to the market in the fastest way. It was your requirements. During this time, we worked and we put a project in situations that it's monolithic. And furthermore, you will pay 10 times more for each feature because it takes sometimes 100 times more time. So today, economically, they understand only money, economically, it's easy to spend 30% of the time and energy to bring it to the parts in place of continue to grow something big and actually unsupportable. It's not our fault. We done it by your request. This is my way how I speak with managers when we really need it. Generally, we have only manual tests in a system. Why? Because automated test doesn't work at all. Why it doesn't work at all, we will talk a little bit later. And a lot of friction in a pipeline. Why? Because each time when we're coming to deploy, it's terrible, it's full of blood. Now, Actually, we have only 3 places where we can separate our application in parts. One of them before the build, it's the libraries. One of them during the build, it's compilation flags, or something like this. And the last one after the build, when it's different services. That's all. But by the way, when we have a monolithic code and would like to come to separate parts of application, we should think about all of these 3 components. There is no one solution. You should implement only this one. This is your microservices. Oh, sorry. Microservices will help us. Yes, will help. But we should think about libraries too, and compilation flags too. Now, very known scale cube. What is the scale cube? 3 axes. First axis, it's actually for DevOps. Because when the load grows, when the number of requests grows, we need additional instances of application or service. It's scalability with load balancing, very simple. This is the x-axis. Y-axis is a division for different services from application. It's also scalability, but scalability and functionality. And the last one, y-axis, z-axis, sorry, it's splitting by SLA for a different group of persons, regionally, geographically, by importance, or whatever. And when we would like to scale our application, it should be answered, what for? For which reason? Because this scalability is a scalability for answer for load. This scalability is answer for a quick deploy, because each part will be less and simply treated. And this one, scalability for a business, for regions, for who's important, who's less important, where we can test. For sure, we will combine this approach to get a result. But you should keep in mind when someone tells you that we need a scalability to grow our system, what for and which direction to use, or combine them, because we are combining 3 of them in our project. So this actually the answer for monolithic code. I will not talk today about methodology, how to go, how to spread the monolithic code for different parts. If someone would like to know it, we will talk about it later, because it's absolutely much more time required. Design test suite. Quite the same picture. Here we have a technical problems. Problems from implementation, bug. Problem from design, refactoring. Yeah. Here we have a request from the business and actually from architecture perspective or for new business approach. We do not talk about this one, we are talking about those. And as close we to the testing with our solution, it will require less money and will be frequent. Very known test pyramid. I thought many projects, and in each project, I thought a manual test, in each of them. I didn't thought in many projects real automation tests, code reviews, reading. Yes, for sure, we have a code coverage, etc., etc., etc. But it's like a right documentation. It's something that's not interesting actually. But it costs less money and it's much quicker, and all energy we should put here and minimal there. This is the wrong direction, but it's the most simple direction. and persons try to go to here. We have no enough QA. This is a major words from developers where something crashes. And then we have ice cream pyramid, yeah, where this is a wrong solution, where a manual test is a huge one. In such approach, continuous delivery doesn't work. If you have no time for unit tests, because the project is small, forget about continuous integration and delivery. It's a waste of time. Now, let's talk about automation QA. You know, I know only two very, very difficult positions to find. One is security engineer, it's amazing, I can't find it 1 year. And another one, it's a good QA engineer. Why? Because it should be developer that perfectly understand your application. He not only writes the tests, he also describe after to developer what's going on. Why? Because many times this is a real mail each morning from automation QA engineer about our 5 streams, testing streams, with problems. And he described why each red one exists. By the way, it's a good solution. I like a red. It means that it's work. Okay. Pink one is, you know, validation wrong. We can live with it for sure. This one, he explained after that here is not a bug actually, because it's parallel streams. They make a correlation each another, and please do not put an eye on it. It's okay. So QA engineer each morning, like in a doctor when he get an X-ray, he write what he see, what's the problem. He sent to all the team explanation what's going on, if the bug exists, because Jenkins much more time, more than required, even give a red sign, not a green. And after it, all developers say me, oh, so we can't believe for continuous integration Jenkins because each time we have a red. Why we have a red each time? Because tests written by one and code written by another. It's from the same requirements, but slightly different. And sometimes we can live with this red. It can go to production, but someone, very important, that who understands the code, he knows what's going on, explain what we got as a result. It's not fully automated, but in such approach from automation QA engineer, it can work. Each day, we got such mails about continuous integration build. The last one is the deployment pipeline. You know, more than 20 years ago, he was an ISO 9009 engineer that comes to our team and told, you know, I wouldn't tell your team how to work. The only 3 things I require from you. First of all, design together with your team how you will do it. Which documentation you will put, which testing you will done, what's the definition of done. It's your responsibility, your team. Design it. After it, please write it down, and after, do it. This approach I use with any of teams that I manage. I do not want to present. Why? Because continuous delivery is a culture. I don't want to put them to the different culture. But what I 100% sure that I would like to make a situation when they put the rules, they agree with these rules, and they work by these rules. As an example, it's a live example of one of our team, Ruby developers, and here's a pipeline. It's not I developed. they developed it. Pull trigger request, check the build, unit test, security test, RSpec test, build the Docker image. Here we begin to come to automation. Run environment and deploy application, run auto test, remove it, migration. Test down application, and if we worked with databases, we need to check migration too. They do it, but after they should work by this rule, developers and QA. I will talk a little bit about common anti-patterns with approaches, such approaches. First of all, long life feature branch. We need feature branches, for sure, because we should check something, try to make any feature. We don't want to correlate with mainstream, but it should not be long life, because each time, each day, it goes farther and farther from the main line, and after, frequently what's happened, we cannot make a merge. We should, from some point, we should make a new development, because we cannot join it together. Branch per environment, terrible. If we have branches per devs, QA, staging, horrible. It won't work with continuous delivery for sure. Shadow process flow or steps. Generally, it shouldn't be automated. It shouldn't be manual. All continuous process requires that it will be automated, but it's not. Why? I don't know, maybe because we are wrong, but I never thought that system fully automated from the point of Git to the production. The people should look in the steps and sometimes make changes in environment to deploy, but these steps should be written. It shouldn't be shadow. All of the teams should know these steps and why they exist. It's absolutely the same like warnings. No warnings in the code should be. No one. Because if we have it, it will be the same problem. In someday, we will get it. We'll get trouble from it. Okay, this is a picture of our continuous integration, continuous delivery scheme. We have a source repository, Git. We have a Jenkins for different applications. Here we have Y-axis, different applications, microservices, and during this build, we made a change, make a check for unit tests, for code coverage, for all other stuff during a compilation. And we put it in the binary artifactory, binary repository. And by the way, we are using console during all the process to store variables, environment variables. Actually, console can do much more than this, but we are using console to have an UI and to simply manage these variables. But unfortunately, we have no other solution. We have a different variables for different environments. Why? Because production environments much bigger than development environment and QA environment. So they are different, but in the same lines, that means that we have a version control over these variables and over this solution for each deploy. In this line, we close a continuous integration and begins to continuous delivery. In continuous delivery, we have a few clusters, 3 clusters actually. Dockerized with Terraform that control Kubernetes, and Kubernetes orchestrate Dockers with Helm with help of Kubernetes. We have also Datadog file bit for monitoring the situation with events and with logs. Also, we have a canary deployment with Kubernetes, because when we coming to production, we slightly with different CLA coming to different part of our services. Yeah. So actually, this is our scheme of continuous integration, continuous delivery. By the way, it's from the picture, it's fully automated. No, believe me, no, because even in a point of QA, we have a manual test as an example. Anyway, we should have it. Okay, conclusion. Effective continuous delivery. When? All teams decide to work by the rule. You should spend the time to explain them it. Unfortunately. Short development life cycle. If you can come to the situation when you deploy every day, you're in a very good position. If your deployment is 1 month or more, it is not continuous delivery, it will not work, and maybe you don't need it. No monolithic code. Again, please remember these 3 points. When something going slow, you need to come to refactoring. Otherwise, you will not have continuous delivery. Forget about it. Do not spend the time and money for it. Correct test suite. Think about different type of testing. Unit test, automation test, code review. I will put it also close to the testing. Real code review, by the way, not trunk-based development. And development pipeline without shadow or manual steps. Manual should be minimal, but it will exist, and at least it should be written in Confluence, and according to the Confluence, it should work. Actually, that's all. You will have this part if it will work. And right now, questions.